All right, this is Mr. Burns. This is the tutorial for activity 216, calculating truss forces, part 1. I'm gonna let you fill in that chart. You can use your notes, you could use PLTW resources. Step 2, we're gonna use equilibrium calculations to solve for the missing reaction forces. We're gonna re-sketch the example below, and we're gonna add the reaction forces, and we're gonna make our free body diagrams for those members. And we are going to do all hand calculations on a separate sheet of paper and put them in these boxes. All right, our truss is redrawn, and so the first thing we need to do is to label our forces and reaction forces acting on this truss. Our PLTW curriculum uses blue for negative forces and red for positive, so I'm going to do the same thing. I've got my first negative force acting on this truss is this 1,000 pounds acting at joint D. That's the biggest of the lines. This one is half as big. This is 500 pounds of force going down. So that's also negative. And then this shorter line right here at joint B is 250 pounds of force. Okay, our reaction forces are going to be here at our pin and roller joints. Okay, the pin here is going to have both a positive reaction force in the X direction and in the Y direction, and then for our roller joint, it is only offering a reaction force in that Y direction. All right, and so now we need to use our equilibrium calculations, our equilibrium equations, to try to solve for some of these missing forces. I'm going to label these. This is going to be the reaction of C in the Y direction. This is going to be the reaction of A in the Y direction, and this is going to be the reaction of A in the X direction. So RAX, RAY, and RCY. We're going to be able to use our equilibrium calculation to solve for these missing forces, and then we're going to go into the method of joints fun that we experienced in class earlier today. So the first one we've got is the summation of all moments, all right, where counterclockwise is positive. It's going to equal 0. We're setting our rotation point at this pinned joint here at point A. All right, and so we've got all of these negative forces that are going to be spinning our truss in a clockwise negative direction. And then we're going to have these, or we're going to have this RCY reaction roller joint that's going to be our pushing it in the counterclockwise direction. All right, and so we're going to set up this calculation. Hopefully we're going to have enough space right here. I'm going to set that up in just a second. All right, so we're going to have 1, 2, 3, 4 total Y direction moment forces from this pin A to add them all up. That's what this symbol means, the summation of add them all up. So again, a moment is the force times its perpendicular distance from that point where it's rotating. So for this first force here, this is going to be 1,000 times 3 feet. So we're going to have 1,000 times 3 feet. That's going to equal 3,000 foot times pounds of force. And if that's going down around this point, so that's going to turn it counterclockwise, or that's going to turn it clockwise rather. So that's going to make this negative. Okay, my second one for B right here, all right, that's 250 pounds of force times 2 plus 3 is 5 feet. Okay, and that's going to equal 1,250 feet times LBF, also clockwise, so that's going to make this also negative. And I've got 500 pounds of force here, times 2, and 2 is 4, and 3 is 7 feet. And so that's going to equal 3,500 feet times pounds of force, also clockwise, so that's also going to be negative. And then my last one here, this is what we're going to be solving for. It's going to be RCY, whatever force that is, and it's going to be in pounds of feet, or it's going to be in pounds of force. And it's going to be times this total distance from the pin, which is 10 feet. Okay, and so we don't know what that equals just yet. So we're going to leave it as that in our subsolve. So we're going to add up this value, this value, this value, and this combination of values, and then we're going to sub and solve. All right, so I'm going to rewrite this as negative 3,000 feet times pounds of force minus 1,250 feet times pounds of force minus 3,500 feet times pounds of force plus whatever RCY times 10 feet is going to be. And we're going to set that all equal to 0 because this truss, this is not moving. All right, it's static. It's, you know, the forces acting on it are going to be equal to the reaction forces. Okay, and so now we just got to get this RCY on the own side of the equal sign here. And so I'm going to move this 3,000 foot-pounds, this negative 1,250, this negative 3,500, and then I'm going to take that whole value, I'm going to divide it by 10 feet. So I'm going to rewrite that right here. All right, so basically we're saying plus 3,000 plus 1,250 plus 350. All right, we're going to include our units. Mr. Burns is going to lose his mind if you guys don't include your units. Okay, and so those cancel out. We move them all over here. You add all those up. I'm rewriting this now as RCY times 10 feet is equal to 7,750 lbf. All right, you will have to check my math on that. And then when you divide 10 feet on both sides, right, this F goes away, these feet go away, and this 0 goes away. So RCY is equal to 775 pounds in the positive direction, so that's going to be a positive number. That's our RCY for this truss. All right, so I've labeled my RCY at 775 pounds in the positive direction, and I used those moment equilibrium calculations to get there. Now I'm going to use my calculations for all forces in the y direction, my equilibrium for my y forces, setting that equal to 0. Remember, up is positive. And so what I need to do is combine all of the forces with an arrow going either up or down and set it equal to 0 and solve for what's unknown. And now that we know RCY, we're going to be able to get RAY. So again, we're just going to add up all of these forces. All right, so that's going to be 1,000. This is a negative, by the way. Negative minus 250. Right, 1,000, 250 minus 500. Okay, plus 775. Right, because that's the one that we just solved for. And then I don't know what that is yet. All right, and so I can say plus RAY, and that's all going to equal 0. And so you just solve for RAY. This is like a piece of cake. You're just going to take all of these numbers and basically subtract 775 from it, and that's going to be RAY. Okay, so that looks like, and RAY is equal to 975, all right, in the positive direction. So we're going to put 9 75 pounds right there going up. While we're here, let's just really quickly, because this is the easiest one in this particular example, let's do our equilibrium calculations for our x directions. All right, where to the right is going to be positive. All right, our forces in the x direction, set those equal to 0. The only one I see is RAX. All right, add up all those forces, set it equal to 0, and guess what? RAX is 0. All right.